Hello, good day. I am Princess Lindsay Morel, and my topic is all about the Fisher's exact test. So, the content of my report would be the objectives, introduction, examples, and problem solvings. Objectives: determine when to use the Fisher's exact test. Use the Fisher's exact test to prove a certain hypothesis. Okay, introduction. Who is Ronald Aylmer Fisher? He was a British polymath who was active as a mathematician, statistician, biologist, geneticist, and academic. For his work in statistics, he has been described as a genius who always single-handedly created the foundations of modern statistical science. Also, he is the father of statistics. What is Fisher's exact test? So Fisher's exact test uses a hypergeometric distribution. It has a 2 by 2 contingency tables. Many packages offer the Fisher's exact test results. However, larger contingency tables with more rows or columns are not included. So Fisher's exact test is a statistical test used to determine whether there is a statistically significant association between the two categorical variables. Also, it is a more rigorous alternative to the chi-square test of independence, and especially useful when the sample size is small or when the expected counts in the contingent tables are small, which is less than by 5, less than to 5 or less than by 5. When to use Fisher's exact test? Okay, the use of Fisher's exact test of two independence is when you have two nominal variables and you want to see whether the proportions of one variable are different depending on the value of the other variable. Also, it is used when the sample size is small or it is less than by 5. Okay, nominal variables are classified observations into discrete categories. So, for example, for this includes the sex. So, the sex values the female and the male. So, the ankle conditions also values the whether it is normal, sprained, or whether it is broken. Okay, Fisher's exact test. So, as you can see, this is the formula on how to get the Fisher's exact test. So, once again, Fisher's exact test is a statistical significance test used in the analysis of contingency tables where the sample sizes are small. Um, okay. Fisher's exact test is used to determine whether or not there is a significant association between two categorical variables. It is typically used as an alternative to the chi-square test of independence. When one or more of the cell counts in a 2 by 2 table is less than by 5. So, Fisher's exact test uses the following null and alternative hypothesis. So, this is the H sub 0, with, which is the null hypothesis. So, the two variables are independent. H sub 1 or H sub A is the alternative hypothesis, so the two variables are not independent. As you can see, we have here a 2 by 2 contingency table. Category 1, Category 2, the group 1, and the group 2. A plus B, C plus D, A plus C, B plus D. And then we have the column total or our total row. A plus B plus C plus D is equal to N. Later, we're gonna discuss about um, how can we conclude that the computation of N. Okay, The one-tailed p-value for Fish's exact test is calculated as p p is equal to a plus b factorial c plus d factorial a plus c factorial b plus d factorial divided by a plus. This produces the same p-value as the CDF of the hypergeometric distribution with the following parameters. So the population size, which is the n, population successes is equal to a plus b, sample sizes is equal to a plus c. Here are the sample sizes. Okay, let's proceed to the problem and solving. Okay, Fisher's exact test example. Supposed to be we want to know whether or not gender is associated with political party preference. We take a simple random sample of 25 voters and survey them on their political party preferences. So, the table below shows the result of the survey. Female, male, female, the Democratic, Republican, and the total. In um, in Democratic there are 4 males. There are 8 males. In Republican there are 9 males, and there are 4 males. So we need to add this one. 4 plus 8 is equal to 12. 9 plus 4 is equal to 13. 13 plus 12 is equal to 25. Okay, here are the steps on how we calculate the Fisher's exact test. Okay, the step 1, we need to define the hypothesis. We will perform Fisher's exact test using the following hypothesis. H sub 0 is our gender and political party preference are independent. H sub 1 is the gender and political party preference that are not independent. So in step 2, we need to calculate the two-tailed p-value. So we can use the Fisher's exact test calculator with the following input. So this is I searched it in Google. So you can search this one, the calculator, Fisher's exact test calculator. In group 1, there are 4 here. 4, category 1, which the male, category 2, the female, and Democratic is the 4 and 8. Republican, the 9 and the 4. Then click calculate. So here are the outcome. One-tailed p-value is equal to 0.081178. And two-tailed p-value is equal to 0.115239. So the two-tailed p-value is 0.115239, which is this. Okay, one-tailed p-value is it is a what do you call this one? It is a greater than or less than, while the two-tailed p-value is divided into two, equally into two. Okay, since this value is less than 0.05, we fail to reject the null hypothesis. We do not have sufficient evidence to say that there is any statistically significant association between gender and political party preferences. Okay, example number 2. You are studying if certain treatment for skin cancer lead to good outcomes. Some patients are given drug X and others are given drug Y. So the patients are cured of cancer or they are not. When you complete the 50 patients, you find that the percentage of patients who were cured and took drug X is it is much higher than the patients who took the drug Y. Okay, let us see the data below. This is a 2 by 2 contingency table. So the drug X, which the cured is have a 45, while the drug Y cured 19 patients, not cured 55, drag y 89. Okay, so we need to sum it up. 45 plus 19 is equal to 64. 45 plus 55 is equal to 100. 19 plus 89 is equal to 108. So, um, look at this. It is much higher than patients who took drug Y. So, drug Y data is much higher than the drug X. So, the second step would be the significant level. In significant level, um, um, in the word problem here, the significance level is it is silent. So, in general rule, it has 0.05. So also we need to check the conditions of Fisher's exact test. So it has a small sample size valid for all sample size. Then let's analyze a 2 by 2 contingency table. So Fisher's exact test, the two-tailed p-value is less than 0.001. The association between rows, groups, and columns outcomes is considered to be extremely statistically significant. So here, again, this is the contingency table, a 2 by 2 contingency table. So we need, first step, we need to state the null and the alternative hypothesis. It is a H sub 0, it is our null hypothesis. So there is no significant association between the treatments and the recovery from the cancer. The other hand, we have a H sub A, which is the alternative hypothesis. There is a significant association between the treatment and the patient's recovery from the cancer. So this is the calculation of this. H sub 0 is equal to P greater than 0.5. H sub A is equal to P less than 0.05. So we need to state the decision's rules. So again, reject the null hypothesis if the computed p-value is less than 0.05. Otherwise, accept the null hypothesis. So, statistical tool, Fisher's exact test is the statistical tool used because the cell has expected frequency of negative 5. Okay, reject, make the decisions to reject or not reject the null hypothesis. So, our assumptions, we need to reject the null hypothesis since the p-value is less than 0.05. In conclusion, at 5% level of significance, there is a strong association between the patient's recovery from the cancer and the treatment administered to them. Okay, let's move forward to the example number 3. So, Fisher's exact test example. You are a clinical pharmacist working in an outpatient pain clinic. You are interested in assessing based on gender the distribution of patients you have that are on pain medication A versus pain medication B. In gender, here our data below is a 2 by 2 contingency table. Gender, the male, the female, pain medication A, pain medication B, and the total. Male, we have 2, pain medication A, and so on and so forth. So the first step we need to do is we will make sure that there are no assumptions or violated. So the total number of patients which our n is equal to negative 20, less than 20, with a 2 by 2 matrix, or our n is greater than 20 but expected cell is 5 or greater is less than 80% of the cell. So state that the null and the alternative hypothesis. So our null, there is no association between patient's gender and pain medication used. Alternative hypothesis, there is an association between patient's gender and pain medication used. So again, there is no alpha. There is no alpha. So in general rule, if there is no alpha stated here, we conclude that it has 0.05% or 0.05 or 5%. Okay, that would be all. Thank you.